machinery with reciprocating components. Shapes propeller blades rotating through water of varying pressure and velocity. Rotating machinery which has not been balanced.
Rotating machinery becoming unbalanced through damage, erosion, or deposits.
Unbalanced power in the cylinder of a diesel engine. Worn bearings in a rotating machinery. Explain that if a vibration becomes excessive, the stresses induced can cause permanent damage. Explain how the vibration may be reduced.
So, let's start.
A reciprocating engine is an engine that uses one or more pistons in order to convert pressure into a rotational motion. They use reciprocating ups and down motion of the pistons to translate this energy. What are the major components of a reciprocating engine? Components of a typical 4-stroke cycle internal combustion piston engine. Crankshaft, exhaust camshaft, intake camshaft, piston, connecting rod, spark plug, water jack for cooling flow, valves. Rotating machine generates primary and secondary force and couples as a result unbalanced rotating masses and unbalanced reciprocating that accelerate and decelerate with each revolution. A reciprocating engine, also often known as a piston engine, is a typical and a heat engine, although there are also pneumatic and hydraulic reciprocating engine that uses one or more reciprocating piston to convert pressure into a rotating motions. This article describes the common features of all types. The main types are the internal combustion engine used extensive in motor vehicles, the steam engine, and the mainstay of the Industrial Revolution and the niche application Stirling engines. Internal combustion engines are further classified in two ways: either a spark plug ignition (SI) engine where the spark plug initiates the combustion, or a compression ignition (CI) engines, where the air within the cylinder is compressed, thus heating it is so that the heated air ignites fuel that is injected then or earlier.
A propeller is a rotating fan-like structure which is used to propel the ship by using the power generated and transmitted by the main engine of the ship. The transmitted power is converted from rotational motion to generate a thrust which imparts momentum to the water, resulting in a force that acts on the ship and pushes it forward. A ship propels of the basic of Bernoulli's third law. A pressure difference is created on the forward and aft side of the blade, and water is accelerated behind the blades. The thrust from the propeller is transmitted to the motor ship through the transmission system, which consists of the rotational motions generated by the main engine, crankshaft, intermediate shaft, and its bearings, stern tube shaft and its bearing, and finally by the propeller itself. A ship can be fitted with 1 or 2 and rarely 3 propellers depending upon the speed and maneuvering requirements of the vessel. Propeller's blades displace water to create the force that move a boat forward. The propeller works by turning torque into thrust. In other words, it converts power from the engine into an action. The action of turning the propellers creates force by moving the flow of water downward in behind the blade. Axle thrust. Axle thrust or fore and aft thrust is the force which causes a ship to move ahead or astern through the water. The propeller blades are shaped to give the most efficiency when moving the ship ahead and less efficiency when going astern.
Unbalance exists when the mass centerline and the geometric centerline do not coincide. What does all that mean? So the geometric centerline is the center of geometry, which for our fan should be right through the center of the shaft. So if we draw a circle around it and say where does it intersect, well it should, if the machine's designed properly, go straight through the center of our shaft. And that's where it also wants to rotate. So there's our geometric centerline. Now our mass centerline should be in the same location. If all the mass is evenly distributed around our machine, then the center of mass would be right through the center of the rotor as well. But when that is not the case, when the geometric center and the mass center are not equal, then when we spin the rotor it will wobble, and that is unbalanced. Now I've got offset to the right here, but of course it can be offset anywhere by any amount. So we need to reduce unbalance because unbalancing increases the stress on the machine, which reduces the life of the machine and the structure. It will damage the structure. It can cause workers in the area to feel that high vibration. It can affect product quality. It can annoy neighbours. I mean, that's pretty extreme unbalance. But in any case, it can certainly damage the bearings and the seals. And if there is any resonance occurring, then the more unbalanced vibration, we get more amplification and therefore much higher vibration. Same as if we have any looseness, then that unbalance drives the ability for it to be loose, if you know what I mean. If it's loose, then we get more motion if there's more unbalanced vibration. Okay, so the other key thing about unbalance is that the forces generated are proportional to the speed squared. So if we double the speed, we get 4 times the amount of force or 4 times the amount of motion, which this little animation is attempting to show. So therefore, as we increase the speed, we will see higher vibration, which may not be something you intend to do, but what it really means is that for a high-speed machine, unbalance is extremely important. It is important to minimize it as much as possible. So, why do we get unbalance? Very commonly in fans, it's just a build-up of dirt. It might be a loss of material, through wear or cavitation or erosion or corrosion or something like that. It might be due to poor castings or incorrect roundness, or, for example, eccentricity. It might be a loss of a part, a balance weight might fall off, a fastener might come away. It might be loss of part of the coupling. It might be, in this case, the way it's been put together, which is not sensible. Of course, this is a little bit obvious. But anyway, there's a lot of causes. We have to correct any mechanical problems that might exist, like missing blades and so on, but then we're going to go through the balance.
Coastal erosion may be caused by hydraulic action, abrasion, impact, and corrosion by wind and water. In other processes, natural or unnatural, also abrasion commonly happen in areas where there are strong wind, loose sand, and soft rocks. The blowing of the million sharp sands grains create a sandblasting effects. Erosion by moving seawater, the action of which largely intensified by this detritus carried by it. Marine corrosion refers to the breakdown or degradation of a metallic material due to an electrochemical reaction when the surrounding environment, ocean. Metal corrodes when it reacts with another substance such as oxygen, hydrogen, an electrical current, or even dirt, and bacterial corrosion can also happen when metals like steel are placed under too much stressing, causing of the materials to crack. An engine must be kept in an excellent mechanical condition to prevent unbalance, a leaky valve or a fuel injector, leaky compression rings, or any other mechanical difficulties will make it impossible for you to balance the load. Unless you secure the engine and dismantle at least a part of it to obtain equal load distribution between individual cylinder, and the clearance tolerance and the general condition of all parts that affect the cycle must be maintained so that very little, if any, variation exists between individual cylinders. Unbalance will occur unless the following conditions are nearly alike as possible for all cylinders. 1. Compression, pressure, fuel injection timing, quantity and quality of the fuel injected, firing pressures. When an engine is in good mechanical condition, a few adjustments will be required. However, after an overhaul in which piston rings or cylinder liners have been renewed, considerable adjustment may be necessary. Worn bearings in a rotation machinery. The bearings of the modern marine engines come with a high load carrying capacity of a good alloy combination SN, EI, FEB, and Juera, which provide excellent embedding and sliding properties. The ship engineers should know the operating hours of a various bearing inside the engine and also plan to check and overhauling procedures accordingly. It has often been seen that the bearing failures or a breakdown occurred well ahead of a running hours. The cost of bearings vary depending upon its position. If any major damage breakdown occurs, the total costing involved increase as the journal pin of the shaft or of the crank web has high chance of getting damaged. In case of severe bearing damage, the engine bed plate can also get damaged. The bearings of a marine engine can be said is wearing down when the lining babbitt or a thin aluminum is worn away by lining scuffing, wiping off lining due to excessive loading, abrasive wear due to contamination of lube oil, melting out of extensive fatigue of lining babbitt due to lack in supply of oil, or high temperature of a bearing when steel to steel contact occurs. What is vibration in ships? The vibrations that originate due to the operation of machinery can be listed under the machinery vibrations. Any machinery that has part moving at a certain frequency induced vibrations. So the main engine, propulsion shafts, gearbox, propeller, pumps, diesel, generators, all machinery transmit vibrations. So what are the two types of vibrations? There are two types of vibration, the whole body vibration and hand-arm vibration. Both can cause ill health. What are the causes of vibrations on ships? Where areas propeller shaft force, bearing force are the most significant factors for vibrations of shaft lines. The pressures fluctuations on the hull surface are the predominant factors for the vibrations of ship structures.
Explain that if vibrations become excessive, the stresses induced can cause permanent damage.
One of the most common and dreaded problems on board ship is the high levels of vibrations.
In the past, there have been ships that have been discarded for years due to an unacceptable level of vibrations, rendering them unsafe for operation. The two most noticeable effects this vibration has on the ship is structural fatigue and discomfort of crew or passengers.
The following precaution helps to reduce the whole body vibration exposure, limits the time spent by the workers on a vibrating surface. Mechanically isolates the vibrating source of surface to reduce exposure. Ensure that the equipment is well maintained to avoid excessive vibration.